Hi, good morning everyone. Today I would like to continue with the exponential Fourier series. Okay, the example 3 given a signal xt equal to 1 plus sine omega naught t plus 2 cos omega naught t plus cos 2 cos omega naught t plus pi over 4 and find its Fourier coefficient. So the difference of this example 3 with the previous example 1 and 2 is the example 1 and 2 is just the single signal. And this example is combined with the sine and cos. Okay, so this question asks you to find the Fourier series coefficient. Okay, in order to do this, you can use the Euler formula to solve, just the Euler formula to solve this question. Okay, now let's do it together. Okay, based on the xt, you have the 1 plus sine. So sine is 1 over 2j exponent j omega naught t minus exponent minus j omega naught t plus for the cos is, okay, you have 2 cos is exponent j omega naught t plus exponent minus j omega naught t over 2, so this one can cancel out, plus with the cos is 1 over 2 exponent j, and then you have j, you have 2 omega naught t, you have 2 omega naught t plus with pi over 4, and then you have exponent minus j 2 omega naught t plus pi over 4. Okay, so you how to do this, how to simplify is, okay, you based on this xt, the expression of xt, so you know that here got omega naught and 2 omega naught, so you can just collect those omega naught minus j omega naught, so you means that you have a j omega naught minus j omega naught, and then you have the j 2 omega naught, and then minus j 2 omega naught. Okay, you collect those, okay, coefficient. So for this one, for the j omega naught t, so you have 1 plus 1 over 2j, and then for the expression of exponent minus j omega naught t, you have this one, and also this one, so you have the 1 minus 1 over 2j, okay, and then plus with this one is 2 omega naught, okay, so 2 omega naught, so I just write down 1 over 2 exponent j 2 omega naught t, and then I multiply in, okay, I multiply in this one, so I have exponent j pi over 4, and then I have half of the exponent minus j 2 omega naught t, and then I have exponent minus j pi over 4. Okay, so I can also simplify again. I want to collect those, so I have 1 plus 2j exponent j omega naught t, and then plus 1 minus okay, exponent minus j omega naught t, and then plus with okay, I think if you write in this way, that would be just good enough. Okay, just good enough. You just need to know the coefficient and group them in terms of omega naught, minus omega naught, 2 omega naught, and minus 2 omega naught. Okay, so you have omega naught minus 2 omega naught and minus omega naught. You have 2 omega naught, and also you have minus 2 omega naught. Okay, so you can write down the Fourier series coefficient. So x0 equal to 1. So this one is referred to here. Okay, there's nothing. And then omega naught. Omega naught means where 1 omega naught is equal to x1. So x1 is equal to this one. You left 1 plus 2j equal to 1 minus j over 2. Okay, 1 over j is equivalent to minus j. Okay, so x negative 1 actually is referred to x minus omega naught. So that is referred to 1 minus 1 over 2j. So this is equivalent to 1 plus j over 2. And then you have x2. x2 you refer to the exponent 2 omega naught. So you have half of the exponent j pi over 4. And then for the negative 2 omega naught, you have half of the exponent minus j pi over 4. Okay? So, okay, what is this means? Do you know exponent j pi over 4? What do you obtain? Do you know what is obtained? What is that? What is the magnitude? Because at the end, you need to find, if the question asks you to plot the Fourier series coefficient, you need to find the magnitude and the phase. All right, you need to find the magnitude and the phase. So from here, you need to know what is the phase and what is the magnitude. Okay, based on this one, you need to plot the magnitude, right? Plot Fourier series coefficient xn. Okay, for the magnitude, x0 is what? X0 is 1. It's a real number. And then x1? x1 x1 is what? x1 you have the complex number is 1 minus half. Okay, 1 minus half j. So you have the a is 1, b is negative half, right? So you can have the square root of 1 square plus half square. So you get 1.12, right? So for the x negative 1, what do you get? It's 1 plus, right? So again is 1 square plus half square. You get 1.12 also. And then for the x2, the magnitude for the x2, if you obtain it's not in a complex, it's if in an exponent, actually you can directly get from here. This is referred to the magnitude. Okay, and this one is referred to the phase. So this means that you have the magnitude of half and the phase is pi over 4. If 1 pi is 180 over 4, so you get 45 degree. Okay. So x2, magnitude of x2 is half, and x negative 2 also half. Then what about the phase? For the phase, this is x0 is a real number, so there's no phase. Okay, so for the x1, you can have the inverse tangent b over a is negative 0.05, a is 1, so you get negative 26.5 degree. For the x minus 1, you get inverse tangent 0.501, so you get 26.5 degree. For the x2, as I told you just now, you get positive 45, and x negative 2, you get negative 45. Okay, in order to plot the Fourier series coefficient for the magnitude, you can put like this. So just now you have x0 is 1, 1, and then you have 1.12, and then 0.5. So this is for the xn, and also for the phase, you have negative 26.5, and for the 2 is positive 45. And this one also the same, 26.5 and negative 45. Okay, you understand now? Alright, thank you for watching. Hope you can understand. Bye bye.